Okay, this is a series of videos, or maybe just one video. We'll see how it goes on strings and a few other things. This corresponds to chapter 7 in the textbook that I mentioned, and the chapter that I've mentioned a few times now. Okay, so let me move these slides over here, and I'll have them on a separate screen, and that's what I'm taking some of my code from. So the first thing that we might talk about is a highfalutin word called concatenation. Concatenation. We've seen that this symbol acts in the way that we expect it to whenever we learn about it in elementary school or whatever. 5 plus 2 prints 7. Very inspirational. But what if we call a string variable named b? If we say string b equal hello, what happens if we say b plus b? This is not such a well-defined thing as integer addition. This plus symbol acts differently here. Okay, so how does it act? Does it take the ASCII value of h, which is the decimal equivalent of the ASCII value? So the character h has the ASCII value 104. So do we take 104? Are we doing something like so this is 104, this is 104, and we add these together and get 208. And 208 has the extended ASCII value of this box drawing character here is what this is called. These are all box drawing characters. I believe that's what they're usually referred to as. Yeah, box drawing characters. These things. I was used on kind of old school GUIs like this to make these lines and these symbols. Okay. Anyways, is that where we're going to get? Let's just take a look. Concatenation joins two strings. It turns out this is the concatenation operator. We can call it addition if we want to be kind of sloppy with our language, but hello, that is concatenation. If we print b plus b plus b, we see, what do we see? We see hello thrice. Not twice, but thrice, 3 times. Okay, so again, this chapter 7 is about strings and a few other things. We're going to get into string functions that are defined for this thing, which is called the string class. Yeah, so we've already seen one of the functions. We've seen b.length. If we spell length correctly, length is it returns an integer, this thing called size t. Let's poke into that actually. Size t, what is this? If I right click, size t equal, okay, size type. Can we look at the definition of this? Eventually we'll see what I'm looking for here. Maybe. Okay. Let's just look it up. We'll see it a few more times if whoever's watching this video stays with me. Size t. Maybe we look up MSVC. See what's the difference between size t and int on Stack Overflow. Okay. Unsigned integral. Okay. Loosely speaking, size t is an integer. Maybe CPP reference will give us a nice answer. Unsigned integer, yeah, it's kind of complicated, but there are reasons that this says size t instead of integer. But let's just be sloppy and think of size t as an integer. Length returns an integer, the length function, and that integer is the number of characters in this string. 1, 2, 3, 4, 5. So this prints 5. We've seen this function before. Yeah, that is 5, the length of the word hello, number of characters in it. Okay, so that's one string function. We have yet to get to what is called string indexing. Getting particular characters in a string. If we say cout b, and we use a new thing called the subscript operator. So I typed an open bracket. This is not a brace, this is a bracket, square bracket if you like. I just call it a bracket. This is a brace, this is a parentheses. Okay, so that's a bracket, and this is called the subscript operator, or it's also called the index operator. And we'll learn all about it. Subscript in chemistry, for instance, there are other uses. We've seen subscripts before, almost certainly. The most common use, I think this is probably what most people are familiar with when they see the word subscript. Nitrogen plus 3 hydrogen molecules yields an ammonia, 2 molecules of ammonia. Okay. The subscript is the small letter there, and it's related to mathematical notation, like the ith element of a set mathematics. So there's something called a set, and subscript notation is commonly used. It's also used in physics. V sub x, the velocity in the x direction, v sub y, the velocity in the y direction. Just given some other uses of this term subscript, because in my opinion, I think that that's helpful. Index, what is an index? What is an index in a textbook? Or an index in publishing? Maybe the Wikipedia article is kind of interesting here. Never heard of this work before. And there's the word software is mentioned here, not very surprisingly. Let's just look up an index in a textbook, and we see, is there a more interesting example? An index in an encyclopedia. Textbook is very vague. Index in an encyclopedia. We have an idea of what this is in a browser. If we go to Wikipedia, which is an encyclopedia, we see, we go to English, and we see, is there an index here? Contents, that would be a sort of index. Lists. This is a sort of index. Culture and the arts takes you to a certain page. Generally, in terms of an old school textbook, if you look up an index, it's got, you look up defenses. I guess this is against, like it's a law book, jurisprudence. You go to page number 52 in order to see information about compulsion defenses. Okay. I don't need to linger on this as long as I'm lingering on it, I don't think. In the index operator. So what happens if we print the 0th index? The 0th character, I'm saying the word 0th. It's a bit of a strange word that mathematicians and physicists use. The 0th index of the string hello. What does this mean? Surely I mean to print the first character in the string. Let me hide some of the previous outputs here. Okay, so we've got the string called hello, and I'm going to print. This means I'm going to print the letter H, right? Well, surprisingly, I print the letter E, and all right, that's a little, yeah, it's a surprising thing. What if I go back a step? 0, H. What if I go back a step to this double quote? Can I print the double quote? Does this make sense? The -1th index. Okay, we see an error that says subscript is out of range. That means I went one step too far. We can't print this double quote. It's not part of the string. The string begins with the character E. The string's length is 0, 1, 2, 3, 4. Excuse me, the string's length is 1, 2, 3, 4, 5. So if we access 5, what does that do? It prints a blank space. What if we go one step further? That's kind of surprising. We go out of bounds. All right. So that's nice to be aware of. Okay, that's a bit about string indexing. I think that's probably pretty clear. Apart from the starting at 0 business, that's a little bit confusing. This L here is it's ambiguous perhaps because we don't know if it's this L or this L. We say 0, 1, 2, 3, so it's that L. If we want to, for some reason, we could say 3 plus 1, which evaluates to 4, which prints that O, not a 0, but an O. And in particular, it's this O. Okay. All right, so let's use a loop and print all of the characters using these indices, these indexes. Using the subscript operator, we could say for int I equals 0 while I is less than b dot length. We increment I, the loop counter variable, and we say cout b at index I, and we perhaps put a tab and then semicolon, and we see what we see. So we see hello printed in this way. And H, which is the 0th index, a tab, and then an E, which is the 1th index, and then 2, the second index, or the first index, if you like. Stop being silly. Okay. So you get an idea of how the index operator works. Perhaps you say b dot length -1, and what does this do? The length of the string is the number of characters, so it's 1, 2, 3, 4, 5. 5 minus 1 is 4, so O. It's like Cheerios. Cheerios. They are just a bunch of O's. Okay. As a joke from the TV show Family Guy that I'm thinking of. Okay. Okay, if we would care to print the uppercase version of that string, we could also use a loop to do that. Similar loop here, except instead of printing this, we say cast to a character, and we call toUpper, a function that we've discussed previously. The string b at the ith index. This syntax is looking a little bit complicated, but it'll be okay. HELLO, all in capital letters. Okay, so appending. Appending is a next topic here. It's a next thing that we could talk about. If we type b.app, append. So append returns a string. Let's ignore this word inline for now, and also the word public. We'll talk about it in Programming Fundamentals 2 in the object-oriented class. Take a const char ptr pointer. Let's also not worry much about this. This is similar to a string. Okay, it returns a string, and then there's this ampersand. Okay, but what does append mean? What does append usually mean? Not upend, like upending something on its side, but append. And interestingly, Google knew what I was trying to do there. Appending to a list. So if you have 1, 2, 3, and you have some space and you append 4, then now you have 1, 2, 3, 4. So append. So I wasn't looking for pictures. Actually, I was looking adding. Append means to add something as an attachment or a supplement. Not like vitamins, but no, perhaps like vitamins. Okay. B.append. Okay. And here we have a string as an option. So let's pass in a string. B.append 1, 2, 3, 4. And what has happened here? What happens if we say B? I was considering adding some explanatory text, but B at the moment is hello. Now, if we say B.append 1, 2, 3, 4, what do we see? We see hello 1, 2, 3, 4. Okay, so that's that. The functioning of the append function seems to be pretty clear. There are some flavors we could add to it. Some arguments, this const char and count. So maybe we play around with this. This should be pretty straightforward. Pass in an integer as the first argument and a character as the second argument. I expect this appends the character A 4 times to the end of the string. So we'll say hello A. We'll see hello okay. So that's called an overload. I can't recall if I've gone into detail on that, but this is one. This is one version of this function. I don't think I have gone into detail this semester on function overloads, but whenever a function has 2 different flavors, so does I refer to them as flavors to make it more approachable and colloquial. This function takes 1 argument. This function, and that argument is a string. This function, when I call the function in this way, it takes 2 arguments, and one of the arguments is an integer and the other argument is a character. So that's called an overload. We have overloaded, or we have not overloaded it because we didn't write the append function. The append function definition is actually really complicated, I'm sure. Yeah, it's very complicated. So append has overloads. It is an overloaded function, and that's a bit of a strange word, but it just means that functions have different ways that you can call them. Okay, so let me just leave that at that, but we'll run this program and see what happens. Hello 1, 2, 3, 4 A. So we could append multiple times to the same string. Is there a prepend? Prepend. Prepending is an operation, and that's known generally by computer programmers. And the word is a bit strange, but prepend means to insert text in the case of a string, it means to add something at the beginning. That's a bit more rare, and not surprisingly, it doesn't appear in the auto completion of this list of functions that the string class has available to it. The string class has all of these things. This is an alphabetized list. Most of these things do what they sound like. Clear probably clears the contents of the string, and we'll look at many of these, not all of them, but many of them. Okay, so that's appending. How about testing? This one isn't particularly useful in my opinion, not for most applications for the common user, but what happens if we say b.clear? And then we say cout b. Okay, we see nothing. So clearing, I've cleared this string. I appended some things and then I undid all my hard work and I just made it this thing called the empty string. The empty string is this right here. It's a double quotes with nothing in it. It's not a blank space. If we actually say b.length, a blank space like this would, or a space, this thing, that was a couple of spaces, that has a length of 1. But this, whenever I call clear, let's see what the length is. The length is 0. Okay. But what if I say b equal a double quote with a space? That is not the empty, what's called the empty string. It's similar to something called the empty set in mathematics, which is this. It's a pair of braces with nothing in between it, and mathematicians often indicate it with a 0 with a slash through it. So the intersection of these two sets, 1, 3, 5, and 2, 4, 6, is the empty set. There are no common elements in this set. Just to give some additional background again. So what is b.length now? There's 1 space there. So the length is 1. And now if I add an additional space, the length is 2. Okay. So the b.clear function works in that way. There is a b.empty function. Do b be empty? Is this true? Empty returns a Boolean. It returns true or false. It returns true if the string is empty. That is, if it's the empty string, and it is right now. So if we say standard bool alpha b.empty, we expect to see true because I just called b.clear on this. So let's see. Do we see true? Yes. If I set b equal to an empty space, it is no longer empty, so that is false. Okay. Apologies if you can hear people talking in the background. Okay, let's talk about the find function. The find function is very valuable. I mean, pretty much all the functions in this list have some function, but look at all these find functions that exist. Find first not of, find first of, find last not of, find last of. It's kind of a zoo, but we're going to look at the find function. As you can see, it has 3 overloads. It has 3 flavors. So there's some complication here. Let's say b.find. What options do we have here? We can pass in a string. Okay. We can pass in this thing called a const char pointer, which we'll talk about later. But let's just think of this const char pointer, this const char asterisk. The PTR means pointer. Let's just think of this as a string. It's not a string, strictly speaking. And this size t, let's think of it as an integer. So it looks like we can pass in a string and then an integer. Okay. But let's just, and we can also pass in a single character. That's what this is. Let's try to find a single character, the character E. And let me move my definition of B down so that we can see, so that we can be reminded of what B is. And we don't need that int a equal 5 and plus 2 anymore. So let's say, so now b is undefined because I just cut it. So b, let's see if we can find the character e in this string. Obviously, a human can see that it's right there. But what if this string was many thousands of lines of text long? It wouldn't be, may not be so easy to find certain characters in that case, like the character Z, a rare character, the most rare character in English words. Okay, so let's see, we print nothing, and that is because we ignored the return value. Find returns an integer, but we didn't print it, so let's print it and see what we see. There's a bit of ambiguity here in the way that a find function is named. Does a find function just say whether or not that character E is inside the string? In that case, it should return a Boolean. It should say, yes, the character E is inside this string. But as you can see, we return an integer. So what you would probably expect is one of two things, actually. If we spelled this word hello, if we misspelled it, a find function could conceivably return the number of times this character occurs inside the string. In this case, it occurs twice. In this case, it occurs thrice. And in this case, it occurs once. Okay. So what is this going to return? It's not necessarily clear. So let's just run it and see. Okay, it returns 1. So it's possibly we're over I, maybe we, if you're with me, if you think in the same way that I think. Maybe we're overthinking by talking about how many occurrences of this character occur in this string, the character E. But let's just play with it a bit and let's find the number. If we print L, are we going to print the number of occurrences? That's another bad example. Let's do this instead. Okay, we print 4. So obviously there are not 4 occurrences of the character E in this string, and rather it is at the 0, 1, 2, 3, 4. It's returning the index, the position of the character E inside this string. And strictly speaking, the string, as it is a character array, which we'll talk about a bit later. Okay, so what about, so it's apparent now that this find function is returning the index of this character. How about the character L? That's an interesting case because the character L occurs twice. So will this find function, it says it returns just a single integer. It says it returns an integer. And we know, or we might know that functions in C++ usually don't return multiple values. They return a single value. Like in a function called int add2 that we've written, and we have some input that we pass in, and we say return a plus 2. This is a single value. It's a single integer. So this is a size t, but I said earlier, let's just think of this as an integer. But yeah, we'll return 0, 1. So will it return 1, or will it return 2, or will it return 1 and 2? This is an interesting thing to think about. It returns 1. All right. In my assignments, I have a word guessing game. And for programs like that, it is very desirable to be able to find, let me put in a word here that's a good example, but it actually makes sense. Maybe LOL, was an acronym, not a word, but an acronym. Okay, so now find L will return 0. So again, this is not related to the number of occurrences of this character, obviously, in this case, because the character L occurs twice. So how do I find the index of the second L right here? I found the index of the first L, it's 0, because we can't start counting in computer programming at 0, generally speaking. the index. The first index is the index 0. So 0, 1, 2, I can find this, of course. Maybe it's a little more unpleasant to find it in this case, to find that third L, because we have to count all of these Z's right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, and I don't even want to do it. Can we find the index of this last L? Can we find the index of the second L? Yes, we can. And we actually use a different flavor of a different overload of the find function in order to do this. So it's related to this offset is what this is called. It's an integer type. Then you can see offset, it's called off, but it doesn't mean like a light switch on off, it means offset. The offset is the position at which we start to search for this character, the first argument. So if we start the search not at index, so the default, if you look at this 0 UI 64, it's initialized to, that's complicated, the UI 64, it gets the 64-bit unsigned integer is what this means. But the default, if my mouse will cooperate with me, the default is 0, that this value 0 that I'm trying to hover on. Okay, the default argument here is 0. It's if you don't type anything there, it gets auto set to 0. But if you type something here, if you start to search at index 1, it starts here and it looks for an L, and it doesn't find an L here, so it moves to the next element. This function moves to the next element using a loop, perhaps looping through the characters. So yeah, we encounter an L at index 2. I'm trying to be very thorough with this. I know I'm probably taking a bit too long for some. So it returns 2. All right, that sounds right. What if we add some O's here? Let's just test this. We can see if we start the search at index 1, which is this argument, and we move to 2 and 3 and 4, the next L is at position 4. Do we see 4? Yes, we do. And we could do the same thing to get the position of that final L, which is, maybe it's like 15 or 16 or something. So instead of starting the search, maybe we hold on to that L value. We say int second L position, the position of the second L that occurs in this string. It is equal to b.find the L that occurs after the second position. And we pass in here the second L position, and let's just see what happens. It's a little non-intuitive. We printed 4 again, so let's add 1 to that so that we start the index, not the search for the L. We don't start it here, we start it here. Okay, that is what that +1 does. So let's rerun this and see. So we see 21. Let's just go through the pain of counting it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 21. Okay. So we have some idea of how the find function works, and you could imagine multiple applications possibly for it. Finding the first instance of a comma in a string, the position at which it occurs. Look for a comma, and we just find where a comma occurs in here, what index. It occurs at index 5. So why do we want to find a comma? I'm not sure, but 0, 1, 2, 3, 4, 5. Okay, so that's the find function. There is an insert function that's also worth going into. Many of these functions are worth going into. Insert takes an off, so it has 8 flavors, and that's quite a bit, 8 overloads. So let's just look at some of these. I'm hitting the down arrow key. The string iterator business is kind of complicated. This is a string. Okay. Return type is a string. Return type is a string. String is string. And then we get back to the string iterator business. That's again complicated. We might talk about it later. Let's just focus on the methods that return the overloads that return strings. So this is an offset. This is a count and a character. So I wonder what this does. The offset, we got some idea of how the offset worked. It was like a starting position, size T count. So perhaps a number of times to insert a particular character, and we specify the start position. This insert function is it's very ambiguous about how it might operate. You could imagine inserting a string in a variety of ways. Can we just say insert ADSF into the string B, and let me just change it back to hello. So maybe this to a human, it obviously means we mean insert the text ADSF at the front of the string like this to make this. Maybe it means insert at the back, which is similar to an append operation. But yeah, so it's interesting. Let's go back to, I think we were on this one. So size T, a start offset. Let's pass in an integer, another integer, and a character and see what happens. Let's say 1 and then 2 and then the character Z. So the character Z will jump out at us. And let's see what happens. What does it return? It returns a string. So it modifies the string B. So HZZELO. Okay. So it seems that after position 1, so 0, 1, we start the insert of a character Z and we insert it 2 times. What happens if we increase this to a 4? Do we insert 4 Z's? Yes. Okay. What happens if we modify this to a 2? And are we overriding or are we inserting? That is, are we overriding the character E, L, and L? No, we're not overriding. We are inserting we're not overwriting. Not doing that. We are inserting. I was wanting to be careful with my pronunciation there because there's a thing called overriding a function, which we'll talk about later in another class. Let me get rid of that because it's not related to what we're doing here. Only mildly related. Okay, so let's play with another variation of the insert function. Can we insert a string? We've inserted a character. We may like to insert a string as well. That is more than one character. Okay, so this const char pointer business and then a count. It's so this is the offset, this is a string, and this is the number of instances we want to insert. It's interesting. This will be the last. There are so many different combinations here. Okay, so let's pass in an integer, a string. This is loosely speaking, it's a string. It's a pointer to a character array. Okay, loosely speaking. Okay, and then count the number of times to insert. So an integer, so insert at starting at the position 2, character. Excuse me, an array, a string, and maybe 3. So I think that this will start at the position. Let's see if we can anticipate this. H, E, and then we start inserting alpha, and then we insert it thrice. So I think this will print this. Let's just see if that works in the way we think it. No. Okay. So that's interesting. So what have we done here? Seems like he alf LLO. Interesting. That didn't work in quite the way I imagined it would. Count a number of characters to replace. Well, anyways, you can for the I don't really care to dig into the insert method in a great amount of detail. The previous example that we did that made some sense to me. I mean, let's insert a string though. Surely this will work. I mean, I say surely, but the order of the arguments matters here. What happens if I try this? It doesn't work. The order of the arguments is wrong. So it's a question that is not so clear if this means insert 2 copies of ASDF. It's probably referring to a starting position. Let's see, and does it overwrite? So hello becomes HE, and we start inserting at index 2 here, and we say ASDF LLO. Okay. All right, so let's change this to 3 and ASDF GHJK. Okay, ASDF GHJK LO. All right, so seems like this makes sense. If we go too far, this might be interesting. Yeah, we went out of bounds. We tried to insert beyond the. We tried to insert at some position that we didn't make space for it, so we tried to insert like somewhere out here. So that makes sense that generated an error. We probably can't do something like this either, inserting to the left. It might, it's out of range, invalid string position. So, yep. Maybe just one more. Okay. Hello ASDF. So that's inserting at the end. So we might have used the append method instead. Okay. That's fine for the insert method. If you have need of the full a great understanding of all of these different flavors of the insert method, you're welcome to play around with them. Yeah, I think the CPP reference webpage gives some nice examples. Yeah, 01E, we're starting with XLMPR. I'm not going to go through this entire thing, but it doesn't show the output. It's kind of too bad. I think maybe C++.com does a better job here, if I remember correctly. Yeah, it shows a whole bunch of, so to be or not to be, that is the question. And it shows a bunch of different variations of the insert function. Insert 10, that is cool. Yeah, and you can see the output there. They also get into something called the string.begin function, and we are not going, and iterators, and we're not going to get into that in this class. Apologies for the background noise, if you can hear that. Okay. A replace function. I think this will be the last function that I talk about for strings. No, we'll talk about substring as well. Erase is also potentially useful. Replace. And again, there are many flavors of this function, so let's just see if we can figure it out. Replace from index 1 to 3 with the string called cat. Maybe this will work in the way that we expect it to. I am definitely not extremely knowledgeable about the different functions here. So H cat O. So we started at the E, started at 1. I think we replaced the next 3 characters, E, L, and L. And we replaced them with the string cat. So what happens if we make this longer? What will we do there? H cat 1, 2, 3, O. What happens if we I think this value here is the number of characters to replace. So what if we just replace 1 character? We see, are we just replacing the E? Yes, it looks like it. So the cat 1, 2, 3. Okay, so we've got an idea how the replace function works. Substring is a pretty nice one. It's much simpler. At least it may not look simple based on this thing that we're seeing here, but it returns a string. So just like subset word in math, a subset of a set. We can look at a Venn diagram and see this, but doesn't quite have what I was hoping for, but one of these images surely does. They're all Venn diagrams. So if you have a set containing the elements 1, 2, 3, 4, then a subset of that set is the elements, the numbers 1 and 2. And similarly, substring, a substring of cat 1, 2, 3 is AT1. And this just, I think it just makes sense. But what are the arguments that we're expecting here? It's an integer and a count. Okay, so count implies that that's not an end position. This is a starting position, but it implies that it's the number of elements beyond the starting position. So let's make this kind of easy to count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what if we take the substring from 2, index 2, which is the third index, which is 0, 1, 2, the third value here, the third character. That's a number, but it's a character in this case. And we want the next 4 characters. And that's how to read that. It's not position 3 to the 5th position. It is count. So let's see. Let's see. AT1, 2. Okay, that was because I did that replacement. So let me comment that out. 2, 3, 4, 5. Okay, so we took 2 to 5. So hopefully this makes some sense. Just to replace it with some text, and I was trying to line this up so that it's easy to see which is which. If we reassign this, if we overwrite this value and put this string in instead, we see CEDE. So if only I knew the alphabet. So we started at 2, CEDE, and went to 5, and it included the 5th index. So, okay. So the substring method is pretty straightforward, I think. Method, function, this is the same thing. Okay, I do go into a little extra tidbit in my slides. So let me just copy that. You might have some natural curiosity about an anagram. about anagrams, and you can have lots of fun with string functions, and lots of string processing goes on in programming. Just because so much of, I mean, you can imagine, so much of the internet consists of text. It consists of lots of images nowadays as well, but um, string processing functions, such as what we've been looking at for the past 30 or 40 minutes, are it's a good thing to have some capability with these potentially. Combing through text on the internet, web scraping is what it's often referred to, is a valuable ability. Humans communicate in words most of the time, often with texts or text. Okay. So this function that I'm referring to, and I referred to the word anagram. Anagram. We'll talk about palindromes later. So what is an anagram? The word least, an anagram of the word least is stale. So STALE. So an anagram is a word which, when rearranged, I can't. I actually struggle to define the word well. But anyways, can we write a program that checks if something is an anagram? We actually can, and I'm just including this as a little tidbit. So standard sort. So this requires pound include algorithm, a header file. Okay, and if we say s1.begin, so this means return, it loosely means the first character in the string, and this end means the last character in the string, very loosely speaking. Okay, so what does it mean to sort a string? It's a good question. What does it mean to say, what if I say cout standard sort B? And I would need to say b.begin and b.end, and don't try not to worry too much about what that means. So after I've sorted B, what does it mean to sort this string right here? It appears that it's already in order. So maybe I should put a Z here instead. Z, A, B, C, D, E, F, G. Okay. So now I would imagine that a sorted version of this string, not sorted like this, but sorted. I would imagine the sorted version of this is A, B, C, D, E, F, G, H, G, H, I, Z. That makes some sense to me. Let's see if that works in the way we think it does. We think it would. Yeah, it printed what I imagined it would, the sorted string. Okay, and we got two E's there because I accidentally typed a second E. So this actually has some neat application to anagram determination. This is a fun application program in my opinion. So let's say string S1 equal least, and string S2 second string equals stale. And we say standard sort s1.begin, and again, don't try not to worry too much about what this stuff means. And if we say cout, not sout, but cout s1, what does it print? It prints AELST, which are the alphabetized characters of the word least. AELST. And you can imagine that since stale has the same letters and it also has the same number of characters, let's add an E to that just to kind of demonstrate that these are no longer English words, but let's see. So AELST. And if we call standard sort on S2 as well, it will be the same thing. This will be the last thing that I do in this video. Once we call our function, which is defined up above, and you may already know where this is going. the way to determine if two words are anagrams of one another. So these are anagrams, and you see S2 is this word right here. It's not a word, it's just a sorted set of characters. Okay, so they're the same. So we could say if S1 after sorting is equal to S2, they are anagrams. And that is true in this case. And this is also nice to point out, it's something I haven't lingered on yet, but two strings being equal to one another means that they contain all of the same characters in the same positions. Okay, and their lengths are the same. Okay, so they are anagrams. If we change this to least ease, they are no longer anagrams, and we don't print anything there. We could print we could say else they are not anagrams. Okay, but there's a Z here, so these two strings are not equal to one another. So let's just test this is anagram function. We could say, and let's make that the only thing that we print here. So instead of passing these to the function, let's prompt the user for them. And we have to be kind of careful here with spaces and the enter key whenever we use CN. It doesn't work as pleasantly as we hope it will necessarily. So we'll see how this goes. I'll enter least and stale, and we'll see if they are anagrams. And again, the CN and the enter key, it's a little bit unpleasant. So it might print false. Okay, so we see sorted versions are AELST and AELST, and they are anagrams. Okay, so that's kind of neat. Let's look up some other anagrams. We'll use single word anagrams. Bored and robed. Okay, let's see. Okay, those are anagrams. Let's make sure that we're not always returning true. They are not anagrams, and the sorted version of that number is this, and the sorted version of that word is this. Okay, so that's a neat program, and you can see a bunch of anagrams here, and there are quite some clever anagrams. That's on the Wikipedia article here for anagrams. New York Times is monkeys right. Church of Scientology, don't want to offend anybody. Coronavirus is carnivorous. And a gentleman is elegant man. 11 plus 2 is equal to 12 plus 1, which is interestingly, both of these are 13. Okay, anyways, you get the point. The very famous one, Tom Marvolo Riddle, is I am Lord Voldemort. Okay. All right. So that's a bit on strings, and I will likely eventually make a second video on strings, string functions, and the remainder of this, the other things that I refer to here are namespaces and some other good stuff included in chapter 7, but I think the string functions are the most interesting aspect.